wabarakatuh. Selamat siang, Bapak, Ibu, dan rekan-rekan semua. Oke, pada kesempatan kali ini kita kedatangan tamu ya, dosen tamu dari UniKL atau University Kuala Lumpur, Malaysia. Jadi pada Talk AI Center kali ini akan diisi oleh dosen tamu tersebut. Oke, sebelum kita mulai talknya, mungkin akan saya bacakan singkat ya biografi dari pemberi talk pada pekan ini, yaitu Ibu Dr. Husna Sarirah Husin. Jadi Ibu Dr. Husna Sarirah Husin ini merupakan dosen di University Kuala Lumpur, Malaysia, pada Departemen Informatics and Analytics, Malaysian Institute of Information Technology. Jadi bidang riset beliau adalah terkait dengan proses mining, kemudian web mining, web analytics, dan juga information systems. Nah, untuk talk pada hari ini berjudul proses mining ya, terkait dengan proses mining, tools dan applications yang bisa digunakan pada proses mining tersebut. Oke, mungkin tidak perlu berlama-lama lagi. Sekarang saya serahkan kepada Ibu Dr. Husna Sarirah Husin untuk memulai sesi talk-nya. Silakan.
Assalamualaikum, terima kasih Dr. Evi. Assalamualaikum Dr. Adila. Thank you for having me today. I went to visit your campus. Tadi saya bersama rakan saya melawat di kampus UI. Sungguh cantik, sungguh besar. So saya share screen lah ya.
Ya, silakan Dr. Husna.
Okay. Okay, bismillahirrahmanirrahim. So, talk saya pada hari ini berkenaan dengan proses mining. The slides are in English, tapi saya akan cuba explain dalam bahasa Malaysia atau bahasa Indonesia lah. Okay, saya Husna Sarirah Husin dari Universiti Kuala Lumpur di Malaysia, and from the Malaysian Institute of Information Technology in one of the campus of UniKL. So UniKL, we have 12 campuses. So MIIT is one of them. Okay, terima kasih atas jemputan. Saya rasa sangat honoured lah to be part of this program. So the talk today is on process mining, tools and application. So saya akan cerita tentang apa itu proses mining dan akan demonstrate one of the tools that is used in process mining, which is called Fluxican Disco. Okay, Fluxican Disco is an open source tool, so boleh download dan boleh guna educators license. Okay, so what is process mining? Okay, so you have heard of, we always hear about data mining, web mining. Okay, so process mining is quite a new research area. Okay, I think less than 15 years. So basically process mining ni is a set of techniques for analyzing operational process based on event logs. Okay, so if kita mahu buat research on process mining, we need to have this input of event logs. So these event logs can be extracted from the database, any information systems, from your ERP, CRM, and also electronic health records. So most of the research conducted in process mining, kebanyakannya daripada area health and also business lah. And also there are some research also in e-commerce when they extract the event logs untuk melihat bagaimana user behavior on the website. Okay, so in simple words, process mining is about finding out how the process are actually performed to discover problems and areas for improvement. So we extract the logs from our IT system. Then from there, we try to analyze what is happening with our system and also identify what are the patterns and trends. Okay, so we can also describe process mining as part of business process management or BPM that applies data science with data mining and machine learning techniques. Okay, so basically we want to dig into the records of the software or also the database to get the understanding of its processes. That's why it's called process mining. Okay, so once we bila kita sudah tahu apakah masalah di dalam proses itu, then we can try to mitigate the problem and also make sure that the process can perform better in the future. Okay, so in BPM, our business process management, so this is the typical process where you have a model. Okay, it's a top-down approach. So you start by designing your process in a high-level model, logical design, and then you will configure your IT system, your software, your hardware, your database based on the model here. And then you will implement the model that you have designed. Okay, so this system then coordinate work between your employees and other resources in your organization. So this is the typical top-down approach for BPM. Okay, but for process mining, it's actually upside down. Okay, so where we analyze the process in a bottom-up fashion. So from here, from the organization, you don't need to have any model. Okay, so we will extract the event logs from your IT system, and then from there we will discover the model based on the historical data that we have. So we will get process model from this data. Okay, so it's called either process model or process map. So in this way, we can identify what is the real process that has been happening and the actual business rules which can be discovered automatically. Okay, so here, let's say we have the existing model. So we have from A to B, and then from A to C and to D and so on. Okay, so from the existing model from our system, from ERP or CRM or database, so we will extract that. Okay, then when we perform our process mining, we will generate the process map, and we can find there's a discrepancy or there's a difference between the actual behavior as compared to what we thought before when we were implementing our system. Okay, so you already have a model of how your process should be performed. So with process mining, we can have an objective information on whether it is really followed as prescribed. Okay, so here we can compare based on our new process map that we have found based on process mining with the existing model that we have before. Okay, so from this comparison, we can identify what are the differences, what are the deviations. Okay, so we can make better decision to improve our system and also our operations. Okay, so process mining is not only for business process, because previously we talked about business process management, but now most of the research, academic research, they use process mining to identify bottlenecks or deadlocks in health information systems, mostly in e-commerce. Okay, so the great thing is that it works for any process that can be observed as long as you have the event logs. Okay, so if you're developing any software applications or embedded systems, okay, so we can analyze the real-life usage process of the consumer devices, medical system, and also large-scale embedded system. Okay, so in our application or any process, it is not observable yet. So we can produce the process map based on the detailed usage data. So here we can give from the process mining or from the process map, we can get the valuable insight on which functionality your user access and how they navigate your product or your website or even your system. Okay, so we have here the instrumented devices. Okay, and from the database, from all this, we can generate the process map. Okay, so there are there are 4 different perspectives that we can focus on process mining. One is the control flow, about the order of the activities, the sequential of the activities, and the goal here is to find the optimal path of performing a process. Okay, so maybe you have like 5 or 6 different stages, the flow or the control flow of the system. So we can identify out of that 6 stages, maybe we can eliminate 1 or 2 to make it more efficient. Okay, the second perspective is the organizational perspective that target the resources involved in the process. Okay, so because we're talking about process mining, there will be stakeholders involved, there will be users involved, okay, such as different users, different departments. Okay, so here we can come up with an optimal structure for the organizational units. Okay, in process mining, based on the event logs, because we have the timestamp, so we can focus on the time perspective. So we can see on the timing, how long does each process take, the duration, and also the frequency of the events. Okay, and finally is the case perspective. We'll consider the properties that are inherent in different cases or type of processes. Okay, so this is one example, a very simple example of an event logs. So from the event logs, we will identify the case ID. Okay, what are the activities, the timestamp. Okay, so sometimes we have two timestamps, the start time and end time. So we can also include that. We can also include the resource or the user or the person in charge of that, and also other data as well. Okay, so if you have used web server logs from the web server, you can find the activities. Okay, the activities can be related to the different URLs that being accessed by the user. The timestamp when the user access the page. Okay, the user can be in the form of IP addresses. Okay, so this is one very simple example of an event logs. Okay, so these are the three techniques, okay, the three common techniques of process mining. One is process discovery. So this process discovery is where we will extract and visualize the process models or process map from the event log. Okay, so this is the first stage of process mining. Okay, so first stage is when you already have cleaned up all your logs, you have done all the data cleaning, data pre-processing, data formatting. Okay, then we can do this process discovery. Then we can go for conformance checking. So here we will compare the actual process with a predefined model to discover any differences or any deviations. So it is used to check if the reality conforms to an existing pattern. So let's say in the beginning you wanted to have like 5 steps, but when we do process discovery, we found out it take 8 or 9 steps. So what are the steps involved? How long does it take? So we can do this conformance checking. So once we have done the conformance checking, we can do enhancement. Okay, this is beyond measuring and comparing. So this is where we focus on extending the model with additional information such as location data, cost, and timing. So here we will add more information on our process map. So this information can be extracted from the event logs itself or other documents from the system. So these techniques will allow us to map our processes and discover gaps and efficiencies in our workflow. Okay, so why is it important? Okay, so previously we have data mining, we have web mining. So in data mining and web mining, we identify the trends, the patterns. Okay, so the same as process mining as well, where we want to understand how business operations are executed by discovering the as-is process diagram based on event data from an IT system. Okay, so basically, if you want to do any process mining activities, you must have this event data or the logs from your IT system. Okay, and then we can analyze data to identify any friction points or any bottlenecks. Okay, and also we can relate these friction points on key performance indicators. Okay, so once we have done the conformance checking, we can understand what is the difference between the desirable and undesirable process outcome. Okay, for example, between orders that are delivered on time versus orders that are delivered late. We can also identify non-compliant behavior, any anomalies, okay, and also understand the root cause of the deviations, and we can quantify the impact of these deviations based on the process performance. And finally, we can do predictive analysis, predict the future performance of a process under different scenarios to make better decisions. Okay, so this is one example scenario. So afterwards, I'm going to show you how to use flexicon discourse. So this is a very simple and straightforward scenario. So for example, you are the manager of a purchasing process. So this is the purchasing process that we have gone through. We have to go through. So we have the requester. Okay, so the requester will send the request to the second person, the manager, for the manager to approve the request. And then the manager will send to the purchasing manager and then forward it to supplier and then to the financial department. Okay, so all these processes will go under the ERP. Okay, so what is the current problem with the process? One is inefficient operation. So if you look at the flow, you have 5 different stages. Okay, so it may be inefficient and it may take a lot of time, and time means money. So we want to try to find ways how to make the process more efficient. Okay, and in terms of compliance, okay, so you were asked to demonstrate that the process is performed according to the purchasing guidelines. So it looks like it follows all the steps, but in reality, does it really comply to all the policies and guidelines? Okay, and also based on the complaints that we have received, it may take longer than expected. Okay, for example, let's say the normal process should be completed within 21 days. Okay, so we don't know whether the time frame is indeed sometimes exceeded, or even is it a widespread problem or just some individual bad experience. So based on these 3 problems or complaints, we can try to identify what are the bottlenecks that are causing all these 3 problems. So what we do, we understand the process in detail. So you want to check whether there are any deviations from the payment guideline. And then we want to make sure that the target or the payment can be achieved within the target day, which is 21 days. Okay, so this is the typical phases in process mining project. So you ask questions, what are the questions, what is the process scope, so which IT systems, okay, and then you will extract the data or the logs via the IT staff. So the data will come in the form of a CSV file. Okay, so if you want to put your file into process mining flexicon disco, it has to be in CSV. Okay, so if you have a text file or Excel file, so make sure you save it as .csv lah. Okay, then once we have the data ready, we can do an analysis and we will discover the as is process. So from this analysis, we can answer the questions whether does the process comply to all the guidelines, why is it taking so long, why is it not meeting the deadlines, and so on. Okay, and finally, we can present the outcome using the process map. Okay, so this is the first stage, okay, the first phase. Okay, we define the goal of the process mining project. So what process are you going to analyze? Okay, for example, if you are doing that purchasing problem, so there are 5 person that you have to go through. So which process or which roles or departments that you want to analyze? Okay, so where does it start? Where does it stop? Okay, so people have often different ideas about the process, even if they use the same name. Okay, like acquisition or purchasing or procurement, it may mean the same thing, but they will have different ideas or different understanding about the process itself. Okay, so what are the main questions that you want to answer and which IT systems are involved? Okay, so that will answer all the questions. Then we will extract the data, which is your CSV file. Okay, so then extract the data from your CSV file, get it from your IT department, and then we will perform the analysis. So the analysis is in flexicon disco. Okay, so I will share you my flexicon disco. I will close this one first. Okay, disco. So you can download disco from this website. Okay, https://fluxican.com/book/read/installation. This is the logo. Okay, Disco is a short for discovery. Okay, so they call it Fluxican Disco lah. Okay, so I have installed this yesterday. Okay, let me check. I can't remember where I put it. Okay, this one Disco. If you install the Fluxican Disco, they will give you one CSV file as a practice. Okay, so you can go here, open file. Okay, so you will get this example log. Okay, this is a Disco setup, so you just click and then just go to the normal process, or we can view the example log. Okay, so the example log is like this. Can you see my Disco screen? If jika ada soalan boleh tanya ya, jangan malu-malu. Okay, so this example log is already clean. Okay, it's very nice. Everything is ready for you to use. So they have case ID. Okay, so if you see here, this remove, so we don't want to remove the column. There's case, activity, timestamp, and resource. Okay, and here is other information that you can use lah in your process map. But for us to do a process mining, you must have at least 3 of these, which is case ID, activity, and timestamp. So we click on this column, case ID, so we will assign it to case. Okay, so let's say if you have a web server logs and your ID is the IP address, so you can also do that lah. You can assign the IP address, the unique IP address to each different user. Okay, and then here activity, so we will assign this to activity. And then here you can see that there are 2 dates, start date and end date. Okay, so let's take the start date first and assign to timestamp. Okay, so in this date you can see it's 9.3.10.805. So we can actually customize the pattern or the format of the timestamp. Okay, so in this example it is date and then dot, month, year, and the hour and the minute. You can choose other variation if you want. So because I'm using the example log, so I just follow this one lah. Okay, and you can click at the bottom here. So this is not much. I think for educational license, they give you up to 1 million rows. Okay, which is quite a lot if you want to start on process mining. Okay, start import. So it will read the log. Okay, so this is what we call as process map. Okay, so it automatically generate this process map for you based on your event log just now. Okay, so we have the start button here, and then the last one is at the bottom here. So I have those in the slide. So this one, okay, like this one is your like apa ni? Okay, so this is the same example because I'm using the example log from Fluxican. Okay, so in this example, you can see the first few lines is on the case ID 339. So all this is based on 339, so that is one case. Okay, and then the first column is the case ID, then we have the activity. Okay, like this one, we have the activity here. And you can see the same case will have different activities. Okay, the first activity, create purchase requisition, analyze purchase requisition, amend purchase requisition. Okay, so the first one, the second one is different. So in process mining, we need at least one activity column. Okay, and then the last column that we need is the time and date. Okay, so here the time and date. So we will take, sorry. the the start timestamp. Okay, so you can also take both timestamp, but for this demonstration, I'll just take the first one lah, the first start timestamp. Okay, so here there must be three items that you need to have. This is minimum. Okay, the case ID, the activity, and timestamp. Okay, so let's say this is a general overview. Okay, here let's say we have case 1, 2, 3. So why is it not sequential? Because this is based on the different timestamp. Let's say case 1, this activity A will happen first, then suddenly there's case 2, then activity A, then case 1 again. So we will extract based on the case and activity the flow of case 1. So it looks like A, and then go to B, go to C, go to D, and then go to E. That's the flow for case 1. So if we look at case 2, which is the one in orange, okay, first is A, C, B, D, E. So that is case 2. Okay, so these colors, this activity means the different activities lah, whether it's request, purchase order, amend purchase order, okay, cancel, and so on. And then we look at case 3. So case 3 has the flow of A, B, C, D, E. So you can see that there are different flows for these 3 different cases. Okay, A, B, C, D, E for case 1. Then for case 2 is A, C, then B, then D, E. Okay, and then for case 3, A, B, C, then D, D, E. Okay, so these are the typical examples that you can find. Let's say if you have an server logs, let's say you have your website, okay, e-commerce website. So case 1, we can replace with user 1. So user 1 will go to the first page, let's say the main page, and then they will go to the item page, and then they will add to cart and so on. So it may be different from each individual users. Okay, so here the first case variation, okay, where you go to A, B, C, D, E lah. So this is the first one. And then the second case is where you go A, C, B, D, E. Okay, and the third case, you can see that here in the third case, the D and D means there is a loop in activity D. It goes to D, but then it goes back to D again before it goes to the next activity, which is activity E. Okay, so besides Flexicon Disco, you can also use other software. Another popular one is called Pro-M, and then another one is Celeron, I think. Okay, but I'm more familiar with Flexicon Disco lah. Okay, it will create the process maps, the ways for you to create process map is almost identical, where you need to have the CSV file and then upload, and then they can automatically generate the process map for you. Okay, so why use Flexicon Disco? It is easily, I think the learning curve is quite easy. It's not that hard. Okay, as long as you have your CSV file, then it's fine. You just put there and then select which is your case, which is your activity, which is your timestamp. It will automatically generate the process map for you. Okay, and then in terms of fidelity, you can create a truthful model from a simple, well-structured process model. Okay, the process map that we create just now, the one generated, is based only from your web server logs. Okay, only from the information that you have selected. Okay, there's no other bias that can deviate your information from the web server logs. Okay, and also in terms of performance. Okay, so here are the parameters that we set, minimum of 3 parameters. Okay, so we can create the process model lah. Okay, so how do we analyze the process map? So let me go back to the Disco again. Okay, so here there are 3 tabs, which is map. So this is the map. Okay, and here you can see the map. Let me make it bigger. Okay. So this is the starting point. So from the first one, the first and the end is always dash line, and also is gray. So this shows the first activity is to inbound call. So there are 3291 cases. Okay, so from this inbound call, it will go to handle case. Okay, so from 4361, you will have 473 to the next activity, which is handle case. And then there's a loop here going back to inbound call at 809. And then from handle case going back to inbound call again. Okay, so there's also from inbound calls go straight until the end, which is 2955 cases. Okay, so from this diagram, the one in the rectangle is the activities, and the arrow will indicate from which activity to the next activity lah. And also the numbers here will indicate how many or the frequency of the activities. Okay, so this one is the process map. From here, you can use the slider here, the activities and the path. So now the activity is 100%, okay, going to the top, so we can see the overall activities of these event logs. If you pull it down, okay, make it smaller, that means it will macam instead of all the overview is 100, so you can see 1, 2, 3, 4, 5, 6 processes or activities. If you slide it down to lower number, then it will become lesser lah. The activities will become lesser, and these numbers, the frequency will be automatically calculated for you. Okay, so instead of here from the 100%, 1, 2, 3, 4, 5, 6, okay, 6 activities. If you slide down, it will become just like, so out for 35.8%, it will go to up to 3 activities. So if you go to the lowest point, there's only 1 activity lah, because all the inbound from the start until the bottom, but we don't know what happens in between. So we don't want that, because we want to see the overall activities that happen throughout the process. Okay, the next slider here is the path. Okay, so here the path, the default is 0%. So this is the default, okay, based on the numbers from the event logs. So if you increase the path, you can see that there are more paths created for you. So here there are 2 paths going to the end of the process map instead of just 1 earlier. So just one, right? So from the start to in the inbound call, and the inbound call go to the endpoint. But if you increase the slider, okay, so to 40.7%, you can see that there are two paths, okay, that generated, one to inbound call, another one to inbound email, and also the one going to the end has also been 2 times lah. Okay, instead of straight away from inbound call to the end, you also have this handle case to the end. So if you go up, okay, and then you go up to the 100%, you can see very complicated path. Okay, so this is what we call as spaghetti. Okay, this is for this example, we only have like 6 activities, then it's not that bad. But if we have like 10 or 20 activities, you can see all the lines merging and also overlapping onto each other. So if you zoom this, okay, so this is very detailed. Can, so instead of the one just now, only a few paths, this is the general one. But if you want to go into more detail, what are the paths taken by each of the activities, you can increase the slider and you can see more paths deviating from different activities up till the end. Okay, and we can also look at this one. Okay, so this is analyzing the process maps. Okay, so I will share my slide with Dr. Evi. Okay, so this is very simple slide about all the how to read the process map. Okay, so we have the canvas. This is the main process map. Okay. Any questions so far? Everyone is so quiet. Okay ke? Okay, so we have, this is the process map. Sorry. Then this is the zoom slider. So you can see that the three tabs here, map, statistics, cases. Okay, so the second one is the zoom slider. You can zoom in and zoom out, or you can also use your mouse. And then this is the third one is the map detail controls, whether in terms of your activities. Okay, that means if you go 100%, it will show you the most frequent activities. If you go down, it will become many more activities lah. And for the path, if it's 0%, it will show you the general frequent activities. But if you go up to 100%, it will generate more lines and more paths for you. Okay, and here we have the process map visualization tools, which we are going to look into. So this is where we can see the frequency. Okay, so this is how to read the process map, start the process. So if it's a start and end, it will be in dash arrows. Okay, so the activities are represented by the boxes. Okay, and the process flow is visualized by the arrow, and the numbers are the number of cases or the frequency from this activity to the next activity. Okay, and the absolute frequencies are displayed in numbers at the arc and also in the activities. So this will be the end of the process. Okay. Okay, so here, for example, here we have 608 cases. Okay, that set all start with the activity create purchase requisition. So when the start one, we have 608 of create purchase requisition, then it divert into two different paths, which is analyze purchase requisition for 382 and create repeat request for quotation requester of 237. Okay, so here because the path where 374 cases have traveled through indicate the main flow, so this is visualized. You can see that the arrow is thicker. Okay, as compared to this one, there's the number is 11, so the arrow is thinner lah. The thicker the arrows means the more frequent it is. Okay, and here we have analyzed request for quotation. Okay, this one here, you can see also the color of the boxes will also give you a different indication. So the more blue it is, that means it is more activities lah, for the more frequent for that activity. So here the most blue is this activity, which is analyze request for quotation 1107 times, which is actually twice as much as the first one, which is create purchase requisition. So why does that double up so much? Okay, so this comes from the dominant loop with activity amend request for quotation requester. Okay, so here we have this one, amend request here, this one at the bottom here, because it goes back to this analyze request for quotation. That's why you have the number very high as compared to the first activity, which only started with 608. Okay, so if you have this loop, it will affect the frequency of the activities and also the efficiency of the activities. Okay, so here, another one, we can see that there's 413 purchase orders completed and end with pay invoice. So actually, there's an arrow here going to the end. Okay, but some are stopped earlier in the process. So you can see the dash arrows. These are the dash arrows. There's two dash arrows here going to the end. Okay, and we can also see that it will stop after analyze request. Okay, the analyze request for quotation is actually this one somewhere here. This one, analyze request quotation here. That this one actually going down to the end here, which is this one. And then this pay invoice is another activity that goes to the end. Okay, so we can adjust the detail, the one that I showed you just now, whether it's activities or path. Okay, and then we can also do a search. Okay, there's a search button here. Let's say you have a lot of activities and you just want to look or you want to find out about particular activities, you can just search here. this one here. There's a search button here. Let's say call outbound. So it will automatically point to the activity that you are looking for. Okay, so this is very small example because they only have 6 activities. But if we have a lot, the search function is very useful lah. Okay, and then frequency matrix. Okay, so we will look into this frequency matrix here. So if you click down, we have case frequency, maximum repetitions, and also case coverage. Okay, so what is frequency? What is the frequency matrix for? Okay. Any question for now? Boleh faham ke? Okay ke?
Ya, sesi Q&A nanti setelah presentasi selesai saja, Dr. Husna.
Okay. Boleh. Okay. Mereka boleh faham ke, Evi? The presentation?
I hope so.
Okay. Okay, tak apa. So we look at the other component of this flexicon, which is this one, frequency matrix. Okay, frequency is the number of times. Okay, so we can look at absolute frequency, case frequency, and maximum repetition. Okay, so here we can see that the numbers and activities and at the path indicate how many times the activity was performed, or what are the particular path that has been traveled respectively throughout the whole process. Okay, but you can also change the number of frequency based on this tree. Okay, so what is it for? So you can use the case frequency to ignore repetitions and just see relative numbers for how many cases pass through which activities and along which path. Okay, so I hope you can see here. Okay, so here there's one here. For example, this one, a man request for quotation requester. So if we look here, what is the frequency of here? Okay, so you just want to see, you don't want to see the repetition, you can focus on this one lah. Okay, and then we have the max repetitions. Okay, so if we choose max repetitions, you can see how many repetitions occurred in your process within the same case. Okay, and also you have this performance matrix, okay, where you can change the performance step. So we have mean duration, median duration, maximum duration, and also mean average duration lah. So mean duration is the minimum, which is the smallest execution time and delays that were measured. Okay, and then we have median duration, which is actually the 50th percentile or the second quartile. Okay, and then we have the mean or average duration and also the maximum duration. Okay, so let's look at this one here. So here, if we look at smaller, okay, so if we look at the case frequency, okay, so we can see, okay, absolute frequency is this one. Okay. So here, this is the absolute frequency. So if we change the case frequency, okay, let's look at this one first. So inbound email is 487. If you look at the normal absolute frequency, but if you look at the case frequency, it will go to 388 lah, and all the numbers on the path will also change according to the one that we choose. So if we choose maximum repetitions, we can see that there are 5 of repetitions, and also case coverage. You can see it in terms of proportion or in terms of percentage. You can also see the performance. Okay, so here the performance is in terms of, you can see 20.1 months, okay, total duration, and then median duration is 39.9 hours. Okay, so these are the median or the 50th percentile for this activity. Okay, the mean duration is 37.7 hours. Okay, and then what is the maximum duration? It may take up to 6 days. Okay, and then finally, what is the minimum duration? Instantly the email will be replied by the person in charge. Okay, you can also look at here the the tab statistics. Okay, so you will see the statistic here of active cases over time. Okay, so you can see all the, you can put scroll your mouse, you can see at this peak what is the active cases on what date. Okay, this is the date from your event logs. Okay, so if you want to see the lowest one here, there's only 18 active cases. Okay, and then you can see the case variance, events per case. Okay, so here one event number of cases is 2,482. You can also look at the one on the right side. Okay, what are the cases? So we see that there are 6 activities. What is the median case duration? What is the mean case duration? What is the start and also end date? So if we scroll down, you can see that there are 3,885 cases with 354 variants. That means out of these 3,885 cases, there are 354 different ways of these cases being handled or being performed. Okay, and then you can see the case duration. So this one is the longest, up to 14 hours. So 10 minutes. So the number of cases solved is 2,000, this one, 2,866. Okay, case utilization, mean activity duration, and also mean waiting time. So if you click here on the activity, you can also see the frequency of the activity. So this one is inbound call, the first activity, which is the most, 4,361 times. Then you have the handle cases. Okay, we can also look at the resources. Okay, just now we did not select the resource because if you remember, if you can recall the first the event log just now, our data too, they have one column resource. So we did not select this one, then it's okay. If we look into cases, okay, so if we look at the first case, this is the first case here. So these are the 3 activities. So you can see the resource is from Helen, what is the date and so on. Okay, so this is the summary lah. There are 3 events. What is the start? What is the duration? What is the active time? So if we look at case 2, and you can see there's only one activity. Okay, and then if you look at case 3, there's also only one. Case 4, only one. Case 5, only one. Case 6, 3 events. You can also look at here how many events for each respective cases. Okay, so if you look at variant 1, okay, variant 1 will have all the ones with only one activity. Okay, which is 2,449 cases. So if you look at variant 2, means all the ones with 2 activities. Kan, if you look at variant 2, so see, you can see case 3 and until down here, they only have 2 events or 2 activities. Okay, so variant 3, they have 128 cases. So this also have 2 events. Although it has the same number of events, but the events are different from variant 2. Okay, different variants. That the variant 2, they have inbound call and inbound call again. So this is a loop, but for variant 3, they also have 2 events, but it is inbound call and also handle case. Okay, so we can also go back to our map. Okay, go down here. Okay, you can also add secondary metrics if you want. Okay, so if you have other metrics, so we have here absolute frequency, case frequency. Okay, so secondary metrics is where you can combine the frequency and also the performance metrics to see how your process maps looks like. Okay, and finally, let's say you want to save this. Okay, you are happy with this, so you want to show to your boss what is the process map here. Let's say you choose 100% for the activities, and for the path, maybe you want to see 50%. Okay, so it will look like this. Okay, so you can export. Okay, so you can export to PDF or to PNG or to JPEG. So let's say if you are writing your paper in LaTeX, then you can export to PDF lah. Okay, so let's say if I export PDF file, so you can save as PDF example log and you can get this process map. Okay, so another example that I can show you is this one. Let me see here, the one paper that I did last time. Where is it? Because this one is the example from Flaxicon. Okay, so where? Where is it? I think this the sample log one. Okay, so I have this log. This is from UniKL online learning platform. Okay, so I have the user ID. So actually I have already cleaned and pre-processed the log lah. Before this, they have like 21 different columns. So I just choose these few columns, which is the user ID. Okay, event name, which is actually the URL. Okay, the component. Okay, and the time created. Okay, so I have the event name here. So I create, there's also another column called component, which is actually the first part of the URL. So this is mod quiz, mod URL, mod resource, and so on. So I can choose user ID as my case, component as my activity, and the time created as my timestamp. So if I import this one, okay, so as you can see, there's 90,000, 100,000. I think this one quite a lot. This is just for half day log, I think. The original data for 1 month is about 47 million rows. Okay, so I just took a little bit and you can see this is what they have created. Okay, there's so many activities here going on. Okay, so let's say if I make it smaller, the first one is this one lah, where the students view the course. Okay, so if I increase activities, just a little bit more, you can see that the first one is where, where's the start? The start is here. Okay, the student will start going to the online learning platform. It will view the course. Okay, and then first view the resources and then view the course. You can see 95,000 frequencies here. Okay, and then some of them go to the forum and some of them go to the course module. Okay, and some of them submitted assignment. Okay, upload the submission, assignment submission. Okay, and they also, this submission created assignment. Okay, and here they answer the quiz. Okay, you can see that most of the activities is viewing the course and also answering the quiz. Okay, so statistics you can see in terms of activity, in terms of events. So what are the events? Okay, so these are the most events performed, which is attempt, they view the course and then view the course again, and then they have the module, and then they have here the quiz. Okay, so if you look at the components, so this is all the components, you can see that the highest is actually when the student attempt the quiz. And then after that is where they view the core. Okay, so if you look at the cases, there are 91 events. Okay, and also each of these events, let's say variant 1, okay, they just view 1. Okay, the second variant is they have 2 events where they viewed the mod resource and then they viewed the course. So all this we can generate from the process map, we can identify the student behavior, how they navigate the online learning. And also sometimes we can compare during which week of the semester. If it's like quiz week, a lot of students will go to the quiz activity instead, and then if it's some assignment submission, it will be different. So we can see the navigation or the behavior of the students will differ in terms of different weeks across the academic calendar. Okay, so this is actually very interesting lah. Okay, so I think that's all from me. Okay, so I've taken like 1 hour of your time. So any questions so far? I'm happy to answer any of your questions.
Oke, ya
Okay.
terima kasih Dr. Husna untuk
Okay.
talk yang diberikan. Jadi sudah dibahas mengenai beberapa hal ya dalam talknya tadi, yaitu mengenai apa itu proses mining, kemudian teknik apa saja yang digunakan dalam proses mining, kenapa itu penting, dan juga sudah disimulasikan ya contoh penggunaan tools Fluxican Disco tadi untuk mengenerate diagram terkait dengan proses mining. Oke. Mungkin sekarang kita masuk ke sesi selanjutnya, yaitu tanya jawab ya. Jadi saya persilahkan bagi yang ingin bertanya kepada Dr. Husna. Oke ya Pak Adila, silakan Pak.
Ya Pak Adila, Dr. Adila, suspense saya. Jangan tanya susah-susah ya.
Tidak. Baik, terima kasih Dr. Husna atas presentasinya. Topik-topik yang saya sendiri juga selalu maksudnya sudah dengar lama tapi tidak pernah sempat mendengarkan lebih jauh gitu. Jadi
Okay.
hal yang baik sekali. Saya tadi tertarik dengan ada 3 hal tadi kan yang dilakukan. Salah satunya itu adalah mengecek compliance tadi itu ya. Jadi misalnya tapi saya mungkin entah saya miss, saya terlewat atau bagaimana, tapi yang saya bayangkan kalau berdasarkan paparan tadi proses mining itu akan menghasilkan pada dasarnya semacam struktur kan, struktur yang menunjukkan alur dan lain-lain begitu ya.
Ya, betul.
Nah, ketika kita mau memeriksa compliance itu berarti kita membandingkan 2 struktur ya.
Ya, betul. Kalau kita nak check compliance means we need to have the process yang current process. Yang ni ialah daripada proses mining ni we generate from the logs. So we can have the, let's say from email processes, email documents boleh. Okay, ataupun daripada the SOP of the company or the organisation, we can see whether they do follow the the steps, ataupun katakan di SOP-nya 5 hari tapi bila kita buat proses mining sebenarnya 7 hari. So we can do a compliance checking lah.
Ya. Nah itu perbandingannya, teknik membandingkannya apakah, soalnya saya kalau membandingkan struktur tadi bentuknya seperti mungkin secara umum seperti graf ya. Jadi membandingkan strukturnya ini apakah membandingkan 2 graf, jadi misalnya melihat apakah ada semacam homomorfisme, isomorphism atau homomorphism antara graf, atau lebih ke yang dibandingkan lebih ke bentuk yang lain begitu.
Sebenarnya saya belum lagi sampai ke conformance checking tu. Actually there's a lot of other steps lah untuk do the conformance checking. So saya baru saja bermain dengan analisis saja. Because on the analysis pun you can see that we can see on the different cases kan, the statistics and also the different variants. Tapi conformance checking tu is another level lah, which I'm trying to discover now. So saya pun baru belajar jugalah. Mungkin kita boleh buat grant sama-sama.
Ya. Baik. Ya, terima kasih.
Okey, terima kasih Dr. Adila.
Oke, terima kasih Pak Adila ya untuk pertanyaannya. Oke, ada lagi yang ingin bertanya kepada Ibu Dr. Husna? Mungkin saya aja yang bertanya kalau gitu, kalau nggak ada pertanyaan. Kalau tadi, ini ada 2 pertanyaan ya Bu Husna. Yang pertama terkait dengan, tadi kan ditunjukkan ya bahwa dengan skor percentage yang berbeda gitu untuk bagian activity dan apa tadi PET ya, itu akan menunjukkan diagram proses yang berbeda juga hasilnya. Nah biasanya umumnya berapa skor presentasi yang paling umum ya dipakai gitu untuk mengenerate katakanlah diagram proses yang cukup optimal?
Kalau untuk the education license, di setakat 100 juta, 1 juta row saja. Tapi selalunya macam saya punya logs ni, actually the original raw data tu I had 40 million rows. Tapi selepas di clean, I think ada 4 million saja. Tapi sebab nak masuk ke flight seeker ni, dia limit dia 1 juta. Jadi saya ambil by week. So 1 week is actually less than 1 million rows. So saya boleh proses, boleh tengok the behavior in 1 week. So dapatlah boleh generate the process map and see all the different activities in different weeks of that month.
Oke, jadi kalau skor activity-nya tadi dan juga
Hmm.
skor path-nya berarti berapa persen yang biasanya umum dipakai gitu untuk mengenerate diagram proses?
Rasanya dalam 50% kot.
Oke, jadi standarnya itu 50% ya, jadi tengah-tengah gitu ya. Oke. Kemudian kalau yang pertanyaan kedua terkait dengan research di bidang proses mining, jadi biasanya apa ya yang menjadi research questionnya yang ditanyakan dalam penelitian tersebut? Apakah terkait dengan proses apa saja yang terjadi gitu dari log yang ada, atau ya apalagi yang biasanya dijadikan pertanyaan penelitian terkait dengan riset-riset proses mining?
Kalau mengenai macam user behavior on website kan, macam website e-commerce ataupun website online learning platform, kita akan tengok what is the activities lah, what are the navigation behavior. Kalau saya pernah buat satu paper, saya guna log online newspaper, so kita nak tengok user tu pergi page mana, page sports ke, national news ke, business news ke, yang tu online website lah. What are the navigational behavior? So kalau macam this learning platform, you want to see which activities yang student buat on the learning platform. Kan? Kalau in terms of health information, dia nak tengok bottleneck. Kebanyakan research yang saya baca for health records, dia nak tengok kat mana, where is the bottleneck for the process. So they will compare the ones from the logs and then the one yang itulah the original process or the current process that yang sedang berlangsung di hospital tersebut.
Oke. Jadi secara umum berarti ada dua hal ya yang mau kita ekstrak di sini. Pertama activity-nya apa, kemudian flow activity-nya bagaimana gitu ya.
Ya, betul. So kita boleh identify ada bottlenecks ke, ataupun kalau macam kita expect ada 8 proses, tapi bila kita generate process map tu sebenarnya ada 12. Kenapa ada extra processes? So ada deviation ataupun ada loop banyak sangat, dia akan pusing-pusing kat situ. So kita cuba nak ni lah, kita akan identify, okay, this one has a lot of looping, dia pusing-pusing, dia tak pergi to the next step. So kita boleh compare with the existing process.
Oke. Kalau hal yang diagram proses yang dijadikan sebagai komparasi itu berarti dapat daripada
proses yang sekarang lah. Maksudnya kita boleh tunjuk kepada stakeholders, okay, sekarang ni you punya proses ni jadi lambat sebab apa, di mana bottlenecknya. Kan, kenapa terlalu banyak frekuensi di activity A atau di activity B. So sebab kita punya process map tu is based on real life events. Kita bukan tak ada tak ada gangguan lain, tak ada benda lain yang masuk, kita ambil straight from the IT department. So we can show them lah, this is the real thing happening, tapi you punya SOP macam ni. So di mana deviationsnya situ.
Jadi compare dengan SOP yang dimiliki oleh company-nya tersebut.
Ya, betul.
Oke, ya, terima kasih Dr. Husna untuk jawabannya.
Terima kasih Dr. Evi.
Oke, mungkin sekarang saya persilakan lagi yang lainnya bagi yang ingin bertanya. Apakah ada lagi yang mau bertanya kepada Dr. Husna? Oke, silakan ya, ada satu orang raise hand, Bunga Karisa, silakan.
Ya, terima kasih. Mohon maaf saya off cam. Saya
Nggak
ingin
apa-apa.
tanya dari proses mining ini, apakah dapat bisa diidentifikasi ya klaster-klaster proses gitu dari data-data yang sudah dipetakan. Terima kasih.
Sorry Evi, can you translate for me? Saya kurang faham
Oh,
soalannya.
Can we make or can we generate a cluster of processes from the diagram of process that we have generated using,
Yes,
for example,
yes,
that
of
tool?
course. Dalam there's one area in process mining. Soalannya berkenaan clustering of process ya.
Whether it is possible to have or to generate a cluster of processes from
Yes.
the diagram of process that we have.
Boleh, sebab one of the research area dalam proses mining ialah event abstraction. So dalam event abstraction tu kita boleh abstract the events kan from the case tu, dan kita boleh clusterkan, nak tengok mana yang instead of tadi katakan ada banyak proses kan, ada banyak aktiviti, yang tu ialah memang raw lah, that means kita tak cluster. So before we generate the process map, kita boleh clusterkan ikut mana yang depends how we nak pakai KNN ke apa ke kan. So from there we can run the process map again and see the flow lah, tengok macam mana. Boleh, betul, there's one area called event abstraction where we cluster the process and then we will when we generate the process map again, dia lebih general lah, tak terlalu banyak sangat flow ataupun aktiviti. Nanti jadi spaghetti, they want to avoid the spaghetti punya cluttered process map, so kita boleh clusterkan dulu. Very good question, thank you Miss Bunga.
terima kasih Dr. Husna.
Sama-sama.
Oke, terkait dengan tadi clustering proses tersebut, berarti apa karakteristiknya suatu proses tersebut dia bisa masuk ke dalam suatu cluster? Apa prosesnya itu yang sekuensial, dia akan masuk ke cluster yang sama atau gimana?
Kalau nak cluster proses tu diseleksikan tak boleh, sebab dia akan generate map terus, tapi di another tu called Pro-M yang tu dia boleh clusterkan. Yang tu saya belum try lah, tapi I have seen presentations where they cluster the process in that software called Pro-M. Dengan lagi satu Celeron, saya rasa ke Celenix, macam itulah nama softwarenya.
Okay, so I mean, what are the characteristics of the processes to be included into the same cluster?
You can set the machine learning algorithm. Let's say you want to use KNN, kan? So then the Pro-M tu will cluster your events or your activities based on the requirement of your clustering.
Oke. Oke. Ya, ada lagi yang mau bertanya kepada Dr. Husna?
Oke, ada lagi?
Oke, tidak ada ya sepertinya.
Evi, boleh kita tangkap gambar semua orang on camera?
Iya, boleh.
Nanti
Ini kebetulan komite daripada AI Center Talk ini, Douglas ya, yang akan mengambil gambar.
Oke, nanti Evi share.
Oke, kalau tidak ada pertanyaan lagi, mungkin akan kita akhiri ya sesi presentasi atau sesi talk AI Center kali ini yang dibawakan oleh Dr. Husna Sarirah Husin. Tapi sebelum itu akan kita ambil gambar sama-sama. Bisa semua, saya minta tolong untuk di turn on cam-nya. Oke, Douglas ya yang akan ambil gambar ya. Silakan ya. Douglas.
Nanti Evi share ya.
Iya, nanti saya share.
Oke, ada lagi yang akan buka kamera? Oke, saya masih tunggu dulu ya. Mungkin tunggu beberapa saat lagi. Oke, sepertinya sudah ya. Ya, saya izin ambil gambar semuanya. Oke, 1, 2, 3. Ada 2 screen. Saya izin ambil satu lagi. 1, 2, 3. Ya, sudah.
Oke.
Okay, thank you.
Oke,
Thank you very much for the opportunity, Dr. Evi, Dr. Adila.
ya terima kasih juga ya Dr. Husna untuk kesempatan waktunya berkunjung ke Fasilkom UI dan juga atas talk-nya tadi. Terima kasih juga untuk para peserta yang sudah hadir di acara talk kali ini. Nanti untuk slide presentasi akan saya share ya ke email para peserta bagi yang tertarik untuk mendalami terkait dengan proses mining. Oke, terima kasih.
Barangkali diiklankan juga Bu Evi yang acara hari Rabunya.
Oh iya, betul. Oh ya, sekalian terima kasih Pak Adila sudah diingatkan. Jadi nanti untuk hari Rabu juga akan ada workshop yang akan diberikan oleh Ibu Dr. Husna Sarirah Husin, yaitu workshop terkait dengan visualisasi menggunakan tools R ya. Jadi kalau kita menulis paper ataupun research report kan seringkali kita perlu untuk menampilkan hasil visualisasi katakanlah yang elegan gitu ya, yang kelihatan saintifik atau ilmiah. Nah, salah satu caranya adalah dengan menggunakan tools R tersebut. Nah, bagi yang tertarik untuk mengikuti workshop tersebut, bisa mendaftar pada sebentar ya, saya kopikan dulu linknya. Sebentar.
Workshopnya offline ya?
Workshopnya offline, ya betul. Workshopnya offline. Pada hari Rabu jam 3.30 sampai jam 5.30 itu ruangannya di gedung baru Fasilkom UI, ruang A2.06 ya, jadi lantai 2 nomor 6. Nah, ini linknya saya kopikan ke chat box. Itu ini saya masih direct message, sorry. Oke, ini linknya saya kopikan ke chat box, jadi silakan bagi yang berminat untuk menghadiri workshop Ibu Husna bisa mendaftarkan diri ke link tersebut ya. Jadi acaranya pada hari Rabu ini jam 3.30 sampai 5.30 di Gedung Baru Fasilkom lantai 2. Oke. Oke, terima kasih semua atas perhatiannya. Terima kasih Dr. Husna, Pak Adila, dan semua peserta yang sudah hadir. Mungkin saya akhiri sampai di sini untuk talk dari Ibu Husna. Assalamualaikum warahmatullahi wabarakatuh.
Terima kasih Dr. Evi, Dr. Adila. Assalamualaikum.
Ya, terima kasih. Waalaikumsalam.
Waalaikumsalam.